Welcome back, guys. This is question 6.1 of chapter 6, because from today we are going to start another chapter, which is chapter 6 of our book, and it is related to the sum continuous probability distributions, in which we will try to understand and try to solve all the questions related to the continuous probability distributions, which include uniform probability distribution, normal probability distribution, exponential probability distribution, and many others. Okay, so let us start it by solving question 6.1. so the statement of this question is: given a continuous uniform distribution, show that a mu is equal to a plus b by 2. Mu means mean of it is a plus b by 2, and sigma square is equal to b minus a whole square divided by 12, means standard deviation is equal to b minus a whole divided by 12. Okay, so we have to start it, and before starting it I have to write what? Let me write the formulas for mu and sigma square, and for continuous probability distribution we know that mu is what? It would be from the lower value of limit to the higher one, and I have to multiply with this x with f of x d of x. Okay, and for mu square of x, this is what? This is the e of x square minus mu whole square. Okay, this mu is also e of x, so therefore this can also be written as e of x square minus e of x whole square. Okay, so this is what? This is sigma square of x. Okay, so these are the two formulas which we are going to use in our question here. So this is for the mean, okay, and this is for what? This is for the standard deviation. Okay, so now before solving this question we have to keep in our mind that what should be the value of f of x. Okay, now in solving part A of my question, first of all let me write the value of f of x. So the value of f of x for the uniform distribution is 1 over b minus a for all the values of x which are greater or equal to a and less than or equal to b. Okay, this is for the uniform probability distribution, which is here from a to b. Okay, this is x, this is f of x, and this is what? This is the probability density function. Now let me solve part A of my question, and this is mu, and using here the limits which are mentioned here, which would be from a to b x, and the value of the f of x is 1 over b minus a d of x. Okay, so this 1 over b minus a is the constant term, it will be outside, so it would be 1 over b minus a, and here the remaining ones will be a b x dx, or 1 over b minus a, and the integral of x is x square divided by 2 from a to b, and ultimately what would we get? We would get 1 over b minus a, and here multiplying it with b square minus a square divided by 2. Okay, as b square minus a square, we can write here that b square minus a square is what? This is b minus a, multiply it with b plus a. Okay, so therefore writing it here, it will be 1 over b minus a multiplying with b minus a b plus a whole divided by 2. Okay, these two will cancel out, and ultimately we would get what? It would be a plus b whole divided by 2, and this is mu, and this is what? This is the proof of the part A of my question, which we have solved by these steps. Okay, so this is the solution of part A of my question. Now let me solve part B of my question. Okay, so this is part B, and the value of sigma square x as given here is sigma square x is equal to ex square minus ex whole square, while ex is given here. Okay, now in order to find the value of sigma square, what do we have to find out? We have to find out the value of ex square, and it is what? It is basically the from A to B x square f of x dx. Okay, let me write the value of f of x, which is here. So it would be x square multiplied by 1 over b minus a d of x, and the limits here again would be from A to B. Okay, so let me solve it. It will be 1 over b minus a multiplying it, this integrating this one, it will be x cube divided by 3 from A to B. Okay, or it would be 1 over b minus a, it is now b cube minus a cube. Okay, so this is what now we have. Okay, so these are multiplied together. Now we know that according to the formula, if we have this a and b, so if it is a cube minus b cube, so it can be written as a minus b a square plus ab plus b square. Okay, this is the formula which we know from the elementary mathematics. So therefore, writing it here, what would we get? It would be 1 minus b minus a, and here it would become b minus a and b square plus ab plus a square. Okay, so these two will cancel out, and ultimately, sorry, here we also have this 3. Okay, this 3 is also included here as well. So ultimately we would get what? The answer of it would be b square plus ab plus a square whole divided by 3, and this is the value for e of x square. Okay, so this is what we know now. Now let me find the value of sigma square, and it is, as we know, that it is ex square minus e of x whole square. Okay, now we know the value of e of x square, the value of mu is also here. So let me put these values. It would be b square plus ab plus a square whole divided by 3 minus a plus b whole square divided by 2 whole square, because this overall is the squared one. Okay, let me simplify it. Okay, so it would be b square plus ab plus a square whole divided by 3 minus a square plus 2ab plus b square, okay, whole divided by 4. Okay, so the LCM of it would be what? It will be 12, or according to the mathematical formulation, it would be b minus a whole square divided by 12, and this is what? This is the sigma square, and this is the proof which we were asked to find out here in this question. Okay, this was what? This was given here in part B of my question, and that is what? That is basically the solution of part B of my question 6.1. If you have any question, you can ask me in the comment box. See you soon.